requirement, and you can call it wherever you want. So that's this picture here, right? So you create callbacks, and you can call them at any point of this loop, as you say, right? You have the data, you get the model, find the loss, get the gradients, do the step, and do the process all over again. So you can call them wherever they are required at any point in this loop. And that's what makes it infinitely customizable, right? Wherever you want to call them. Okay, so let us see how Jeremy has taken this forward for us in terms of callbacks. So he says, let us first take something called a callback. Let us make a class out of it and describe events or methods for that, right? We can then wrap this callback in something called a callback handler. And again, this callback handler has separate events, right? And then what we will do is refactor this fit function that we have here, which already is optimized for now, with the use of these callbacks, right? So that's what is the flow of what we're going to see in the callbacks. So these are the codes that are given for callback and the callback handler. So here is a class called callback. You can see that it has multiple events or methods, begin fit, after fit, begin epoch, and so forth. Then you have something called a callback handler. What it will do is it will take in a callback. So you can see here in the init function, it takes in something called CBS, which is basically nothing but a callback, right? And then it has its own events. There are a number of events or methods that has been defined for this callback handler. And then it goes on to implement an instance of this callback called test callback. Now, in a test callback, he overwrites the method of begin fit with its own method called given fit. And he overwrites the method called after step here with its own method, right? So these are the two additional things he does here, but otherwise it is able to retain all the methods of the callback because it's an instance of the callback, right? So that's what he has defined here. And then this is the refactoring, right? So you have this fit function. What he takes is takes this particular section and he says, I'm going to refactor it into what can be done per batch. So he calls it one batch. And then he writes a lot of callbacks into it, right? There is a begin batch, learn loss function, learn.model, after loss, after backward, after step, etc. So he writes it all the way. Then he says, now I don't have to do it just for one batch. I have to do it for all the batches. So he writes another function called all batches, and he uses this one batch here, right? So that's the refactoring that he does. So he takes this existing bit function, takes in this particular loop, which is for one batch, writes it separately, and then repurposes it in another function called all batches. So that's the refactoring. So let us see how all of this helps. And you can stop me wherever you feel that it's not clear to you. Okay, so this is the fit function. Let us see what it does, right? So when we start with the fit function, it says, if not of callback.begin fit of learn, right? So basically, when I initiate this fit, I need to pass on this callback here. So what do? I'm actually doing a callback handler of a test callback. So my callback function within the fit is a callback handler, which again calls in something called a test callback, right? So that's my callback function. So first what it does is, when we come here, begin fit, it calls this callback handler dot begin fit, right? Now let us go to the code. This is the code for callback handler dot begin fit, right? So it starts this, it goes through this loop, comes to this place, says res is equal to true, and then it again says, now I'm going to check this for all my callbacks within me, right? So self.cbs is nothing but the callback within the callback handler, which in our case is the test callback. So it goes here, checks for this callback. There is only one in our case, and it says my res, which I have declared here to be true, now has to be checked for my callback function and the specific method called begin fit within that callback, right? So if you come here, I have this begin fit function in the test callback. I start this. I say, now I am not happy with just my begin fit. I have to go to my super. Super here is nothing but my callback of which I'm an instance. And it does this begin fit. So it returns a true value. It takes a true value, takes a variable called n iters, sets it to 0, basically counts the number of iterations, and then returns true. So if I come here, already I have defined this rest to be true, and my cb.beginFit is also responding back as true. So true and true becomes true, right? So I have something that is returning me true for this beginFit function. So it takes this if not true. So then it becomes false, which means that this particular line doesn't get executed, right? So this does not get executed. It goes directly here saying, can I check my epochs? So here it goes into the epoch. I have only one epoch here, right? Because if I see the method, I have written only one epoch. So it goes and checks the method called begin epoch internally for the callback handler. And that is what I have mentioned here, right? So it goes and checks for the callback handler dot begin epoch. Now remember, in the loop, it has to go and check the same method for the callback within it, which is the test callback. But if you see here, the test callback has no method called begin epoch. But the super, or the mother of this particular test callback, has a method called begin epoch. So that is what it will take. So here it returns true. So that's what I said. I have done this strike through here, saying that I've checked this. I don't find this here, but I will take that from the callback, which is the super method of this test callback, right? And it does for each of these callback functions, right? So if you see the various callback functions here, I have begin epoch. Then if I go to all batches, in all batches, I have all of this. I have begin batch again. I have after loss. I have after backward. I have after step. And then finally, I have something called after fit, right? So all of this is there. So that all of these methods will be checked one by one here, right? So I will check my begin batch. I will check my after loss. I will check my after backward. I will check my after after epoch, and then finally to after fit. Now, in all of these cases, there is nothing that is coming as an output for us to see tangibly. There are iterations which returns a Boolean value of true. There is fixation of values. But ultimately, what happens is only in this callback function called after fit, it prints the iterations. So if you come back here, it is only here in this after step method of test callback. It takes in the number of iterations, appends them after every step, checks for the 10th such iteration. If it is more than or equal to 10, it stops there. And before it stops, it prints. So that is what happens when you execute the loop there. It'll show you. So let me show you my Jupyter notebook so that you understand it better. I'm going to take out this debug method because it's going to take a lot of time for us to do the debug. And that's what it does, right? It prints these iterations one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're interested to understand, or this is the way I understood this process, all you need to do is to go and say %debug, and you run it. And then you'll be able to see what happens. So I step here. I'm able to see it is calling the first callback handler. It is initting itself. It is going and checking how many callbacks I have within it. So I can go and check here, what is my CBS? So I know that I have a test callback. It then goes and checks if I have appended it. So I can go and check that, say if I have appended my self.cbs, which is now the test callback method. I can also check what is my self here, where am I? And it'll tell you I'm in the callback handler, right? So this is how we can go and check how the interplay happens. Now, this is something that I would recommend that you do, because here we have a function that calls another function, which calls another function, and there is a lot of looping within it. So this is a very good method for you to understand what happens here. But basically, to summarize what happens is what I have done here. This is what happens. So you have the callback handler starting a method, and then it goes, when it loops, it goes and finds the callback within it and checks the same method, and then goes on. But what we see tangibly is only here in this called after fit, where it prints, right? So that's the entire callback that has been kind of explained. So before I go to the runner, any questions here?
Vijay, on chat window, it's fine. I think it's getting answered, but everybody feel free to unmute and ask if you have any question. Okay, move ahead, Vijay.
Okay, great, fine. So great. So you know how Jeremy is. He's never satisfied, right? So he looks at the code. He says, I've implemented a callback. I am looking at how I have implemented the callbacks within Fast.ai. So he looks at this. This is exactly what we just saw before, right? He says that I have a method and I have a callback. I have a method, I have a callback. I have a method, I have a callback. And he says this is not the right way to do it. Basically, the right way to do it is the callback should be a class, and all of this should be methods within that class, right? Or basically make these the callbacks call these methods instead of the other way around. That should be the right way of doing it. And that's what he says. He comes up with this concept called runner. This is not now available in Fast.ai, but is going to be there in the future versions, right? So let us see what this runner is. So here you have a runner defined, right? So basically what it does is it first defines a callback. And I'm talking about the example that we're going to see. So there is a callback that is defined. Then you have an instance of a callback called TWiML callback and average stats callback, right? So that's instance of a callback that you create. And this average stats callback will again call a function for just calculating the metrics. And what he does is he assigns this callback to the runner, right? That is the method that he follows. If you were to look at it very at a very high level. And let us now see exactly how this works individually. So here you have the callback method that you have defined. Here you have the two instances of the callback, right? The average stats callback and the TWiML callback. And then this average stats callback in turn is connected to this average stats class, where you are able to calculate your loss and total metrics, right? So that's the play for us. And let us go one by one and see what happens. Okay, so here is my learn. I am initiating the learner. I am calling the average stats callback and passing in a metric called accuracy. That's what I want to check. And I then assign this, callbacks called stats to the runner. That's what I do, right? And then I call run.fit. So when I do this, what happens is I have started this runner. I have assigned these two callbacks to this runner, TWiML callback and average stats callback. And then when I come to this code, if you start here, it says for callbacks in self.callback. So this is this. There are two callbacks, TWiML callback and average stats callback. And I have assigned the runner of both of these callbacks to be this runner. Then I come to the next line and I say if self begin fit. Now this is again a change of syntax for us. Instead of calling self.beginFit or cb.beginFit, you're asking self.beginFit, right? So basically what happens is this is where this calls the call function. So as we know, the call function is nothing but it allows us to treat an object is this, to be like a function, right? So what happens is this begin fit gets passed here. The CB underscore name is nothing but begin fit. And then it goes and checks whether this begin fit method exists in these two callbacks. So that's what it does. So you have the begin fit. It goes and checks, is this method available in TWiML callback? Is this method available in average stats callback? Is there a function attached to it? Does it return something? If the answer to both is yes, then return true. So in our case, for TWiML callback, it returns true. For average stats callback, it returns false. But at the end of the day, whatever happens, I return false. If you see the code, it returns false at the end of the day. Whatever happens here, at the final call, it returns false. So I get a false anytime, right? And let us see why it is. So I go to the next one called begin epoch, right? Again, it goes through the same loop. It returns false. Now, what happens when it returns false? Here, I have a begin epoch. So if not of false becomes true, right? So because it is true, this gets executed. The self.all batches starts getting executed. Now, what is the self.all batches? It is this, right? It is basically calling in a one batch, and a one batch has all of this. And again, in a one batch, you have all of these callbacks: begin batch, after pred, after loss, after backward, after step. And all of this goes through the same iteration that I have drawn for you here, right? So they go through all of these iterations. But importantly, for us to understand, you have to just take in two things. It takes after loss, this method called after loss, and then it sees, am I in the training or am I in the validation? And then I say, I want training stats if I'm in the training method or mode, sorry. And I want validation stats if I'm in the validation mode. So that's what it says. And then it says, I want to start accumulating the stats, right? What are the stats? Total loss, the count of the batch, and the metrics or the accuracy that is calculated per batch, right? So in the accumulate method here, if you see, this is the accumulate method. It takes this loss of this particular batch, but it multiplies that with the batch number or the batch size, right? And it appends the batch count to this count. And then it also takes the average accuracy and multiplies that with the batch size. So everywhere in a batch, it takes in the metric that is got and multiplies that with the batch size. So this is the change that we're doing. Previously, we didn't used to do it because we are not accounted for the fact that each batch could be different, but now we are accounting for that, right? So here it starts accumulating all of this. And then it goes to this callback called after epoch, right? So let us see this after epoch. Here, this is the after epoch. Now, the answer will be false for this. So let us see what happens. So it says if self after epoch. So here, I have to get a true for this to break, meaning I have to stop my loop and get out of it. But what happens here is by default, it is false. So this becomes false, so I don't break. So what happens is this function gets executed, right? So I have a print method that gives me self.train stats and self.valid stats after the epoch. Now, if you see the way it is defined here in the average stats class, what happens at this case is when I say print something, then it calls this dunder REPR dunder, and it says if I'm in train, print train, if I'm in valid, print valid, and give me the average stats. Now we saw in accumulate, we have a list that takes in the loss, the metric, multiplies them with the batch number or the batch size of that batch and stores them. So I have a continuous storage of this. What I do here in the average stats is take them and I divide them with the total count, right? So therefore I get the average stats and account for the variation of the batch sizes. So when I do this for the epoch, I sum it up because I no longer am dependent on the batch. I sum it up together and I do it for the self.count. And I'm able to get here the correct value of the stats, whether it is the loss or whether it is the metric. So that's what it happens at the average stats callback. So if you go back to the so let me execute it. So this is what happens, right? So when I run it, I get the correct metric of the loss and the average accuracy, but I have accommodated for the variation in the batch size. So that's what I get, right? So if you go back here, that's the output that I get. But again, there is a refactoring. You know that you can pass in a partial function and say, I only want the accuracy to be included in this average stats callback because it needs a metric. And then I again refactor for that particular, improvisation or optimization of the code. And then I can do the same run.fit. So that's how a runner happens. So we saw callbacks and an improved version of it using a runner. So this is what this notebook called callback achieves. Any questions here?
I don't believe there are any questions. Yeah,
Okay.
if you do have a question that hasn't been mentioned in the chat, you want to just shout out now and then.
John, you're speaking really far away. I cannot hear you.
Okay, sorry.
Okay, so I assume there are no questions. I'll continue.
Yeah.
Okay, great.
There was one step. Sorry, there was one step where you checked F and F of double braces, which returned both as false irrespective of whatever we did. Okay, the slide, yes. So
yes.
The last line you mentioned, the last before one line, it's mentioned that if F and F of brackets return true. So can you tell me the reason why there is separate F of brackets there?
Okay, so basically what it says is there a method and does it do something, right? Does it return something? In our cases, if you see, it basically returns none, right? If you see here, if I have this methods here, begin epoch, after loss, or whatever, it does initialization, it does calculation, but it does not return anything at the end of the day.
Right, got it. Thanks.
Okay, let me go forward. So we are now in a very interesting section called annealing. So if you've understood callbacks, annealing is very simple, right? So here we just do two things. We write two callbacks, okay? And I've explained that here. So you have a callback called recorder, and you have a callback called parameter scheduler or param scheduler, right? Now, what we do here is, in the recorder, we initiate it with a list that keeps track of the learning rate and the loss every time fit is called. So that's the first thing it does. Every time the batch is run, it takes the last value of the learning rate in the batch and then the last for that batch and appends that to the list. Now this list again is a continuation. So we have the learning rate and loss for every batch, every epoch in the fit function. And then it has a method for plotting this. So you can plot the learning rates and the losses. That's what the recorder does. So if you see here, this is what it does. So it initializes itself. It keeps track of the last used learning rate in the batch. It appends the loss of the batch. And then since it keeps track of this, you can plot it at any point of time, right? That's what is a recorder. A param scheduler, again, very simple. It says, I will initiate myself with a parameter that I like to monitor or a parameter that I like to schedule, but it will have a scheduling function. So there are two things. I have a parameter and I have a scheduling function. And it says every time a batch begins, I will check whether it is training or whether it is validation. If it is training, I will call this parameter groups in the optimizer, right? So if you remember the Jupyter notebook that John had showed, when he did optim.sgd and question mark, there were a number of parameter groups. So it's in the parameter group, it will check for the parameter that we're monitoring. In our case, it's learning rate. So it will check which parameter group has this parameter called learning rate. And it says, I will assign the value of the output of the scheduling function to this parameter. That's what a parameter scheduler does, right? It's a very simple, kind of formula. So let's go to the Jupyter notebook. Sorry. Yeah, so this is what it is. It takes two of this, and then he does some refactoring decoration with the scheduling function. So one is a linear scheduler, the other is a cosine scheduler, one is a no scheduler, the other is an exponential scheduler, and all that. And then finally he says, I'm going to have a combination of schedules, one which is a cosine scheduler, but this cosine scheduler will apply based on the progress I have made. So I have progress in terms of percentage. In one case, it's 30%, the other is 70%. And I will say, I will apply this particular scheduler for the learning rate, provided I have reached this value, and then I've applied this, provided I have reached this value. That's what it does, right? And then it kind of gets the value for us going forward. So that's what this annealing is. And a lot of it is dependent on ourselves understanding this callbacks, right? If we understood callbacks, annealing is a very simple thing to understand. So that's the whole bit to callbacks, runner, and annealing. Any questions?
From a chat window, you find Vijay. Guys, unmute yourself and then ask away.
I have a question. In terms of the annealing technique, are you referring to the to simulated annealing, the optimization technique?
Yes. So basically, the annealing technique is where we are using the differential learning rate based on how the curve is. So if you see the notebook.
Unfortunately, I can't see it. I'm connected via phone, but I will watch it on YouTube. But just to be clear, so that I can follow you, we're talking about simulated annealing here, right?
Yes, the learning rate annealing. So okay, I basically start the learning rate high. Yes, correct.
Thanks. Yeah. That was it. You can go ahead.
Sure, thanks. So I have done my part of the lessons. Any other questions I can answer, or I can continue it separately in the chat, in the Slack channel.
No, excellent. Thank you, Vijay. So thanks, I think John. Perhaps we give everyone. Oh, yeah. So.
Yeah, thank you, Vijay, very much.
Who's on a flight?
Sorry, you need to mute me right now.
Okay, great. All right. Okay, so if no one has any other questions, then let's call that a day. Does anyone have anything that they'd like to present for next week? If you're not sure, or if you'd like to do that later, then just again, I think just on the Slack channel, that would be great. I believe it's Joseph next week who's hosting.
Oh, Vijay, I have a quick question.
Sure, go ahead.
Yeah. So in the last example, in the example of combined scheduler, how would learning rate change?
Okay, so let me bring up the notebook just a minute. Are you able to see the notebook?
Yes.
Okay. Okay, so let me see what the code is, right? So the code is, I have a combination schedule of persons and scheduler. So the percentage is nothing but 30% into something or 70% into something. And I have a cosine value of 0.3, 0.6, and 0.6.2. Now, remember, when I do the function of scheduling, I have a start, I have an end, and I have a position. Correct? So basically what it does is, if I'm at 30% of the position, I apply the start and end, and I get a value which I apply to my learning rate. If I'm at 70% of the position, then I have a start and an end which I apply to my learning rate. So I am able to then combine this together to be able to get my learning rate up or get my learning rate down, as the case may be, depending upon where I am in that epoch or in that iteration.
Okay, so that's percent of the current epoch, right?
Yes, because if you see here, the scheduling function, it says it's self.anyEpoch / self.epochs. So I think I am assuming it to be 1.3 and 1.7 or 2.3 or 2.7, depending on where you are.
Okay. Cool. Thank you.
Okay, brilliant. Well, if there are no other questions, thank you again, Vijay. Appreciate you going through that the difficult section for everyone.